So today we chat inferences. So I guess it would probably be a good idea to figure out first here at the beginning what that is. So when we start to get data or information, sometimes we're not just going to have it handed to us. Sometimes we're going to have to find it ourselves. But when we're looking for it, we have what's called a population. It's the whole group. So if we were talking about, a population for transitional math class, y'all would be the population, okay? All of us. However, sometimes, though, you can't collect data on an entire population, okay? We're in the middle of an election, but you can't go to every single person and ask their opinion on something. That'd just be crazy. It'd be a long time.
You could.
Oof, no, that'd take a long time, though. We'd be sampling people till the next election. So instead, sometimes you do a smaller part of that population to get going things, or what we call a sample. Okay, this is what you're going to see more times than not. And so from that sample, we can infer certain types of information. So this inference that we're talking about is a conclusion, okay? We can come to some sort of an idea based on the evidence and reasoning. Then we can make an inference based on the samples, just like we would whenever we get information. The nice thing about an inference in these situations are it's not just your personal opinion or one or two people. Normally, you get a group of people together and you kind of figure out, okay, what's the group thing here? And we can do that with a fairly small set. So, for instance, this is a good example. We get fan around here, we get surveys all the time on things, but in other places too. Streaming service company emails a survey to its subscribers. Hopefully you open the email and answer it. We'll see. Subscribers were asked which type of TV shows they're most likely to subscribe to. From the completed surveys, 40 are randomly selected to review. The results are shown in the table below. So, they watch cooking shows, sports shows, comedy shows, reality shows. Now, the subscription service currently offers 120 different channels. Right, true, or false for each inference based on the information given. Now, sometimes we're going to be able to just look at the chart and figure it out. Other times, we're going to have to do a little math here to figure this out. I'm a crazy person. I always do all this math in advance, but that's not always the best use of my time. So let's see what we got here. Of the 120 channels available, approximately 25% should be related to cooking. You're like, okay, I could sort of just throw something out there, but here's a couple of ways I could do this. Just a couple. And you got to kind of figure out as you go along which way you'd like best. Me, I'm going to look at this, and I see there's 40 total people. So what I'd like to do is, I'd kind of like to know, since I'm seeing percentages show up, hey, what percent of the subscribers does each of these represent so I can figure this out? So I'm going to take each of these numbers and I'm going to divide by the total number of people. So, because I know that when I do this division, the decimal is telling me the percentage. I'm just moving my decimal point a couple places to the right or multiplying it by 100 to tell me the percent. So this is how I can figure out what percentage of people tend to like each of the parts. And again, the decimal I can just multiply by 100. Do I have one more color? I do. And if we've done our math right, we should be able to add up the percentages, and they should equal a whole. They should equal 100. Now, I'm hoping that's going to help me do some stuff that I'm not going to have to do a whole lot of other math, but I guess we're not going to find out until we get in here a little bit. So if the 120 channels available, 25% should be related to cooking. Cooking, about 25% of our subscribers like it. So yeah, that's probably something I'd go along with. I could have, if I wanted to, just kind of on a side note here, I could sit there and say, hey, 25%, because we go back to our percentage of the whole that we've done. And I could say, hey, there's 120 channels available. And I could figure it out this way too, but I'm kind of doing the same thing that I did up above. I'll just kind of do it quick over here. And so I'd be like, well, that'd be like 30 channels. Now, did that really tell me anything that time? No, this actually helped me more. So for this instance, I'd stay away from that myself. But that's something we're just kind of figuring out. More than 40% of the subscribers are likely to watch sports channels. So check out our percentages from up above. Is the sports over 40? No. In the ballpark, but it's not over 40. It's 37 and a half. Kind of getting a little on the skinny in there, but that's okay. To meet the needs of subscribers, the service should offer 27 comedy channels. Okay, let's simplify this again. There's 120 channels available. So if we're checking to see if 27 should be comedy, let's see what percentage that would be. So should 22.5% of the stations be for comedy? Man, that's like spot on. Somebody was doing their homework. All right. But I'm just basically using the information I got from the chart and making some percentages to work, oops, bump that over, to work that out. The ratio of sports channels to cooking channels should be 3:2. Now remember, we can write this in a fraction form too, and that's kind of important here because sports channels, okay, now you're like, Hardy, that's not the channels, that's the number of subscribers. But work with me here. So if I do sports to cooking, so if I take that 15 to 10 and I make it a fraction and I reduce it on the calculator. Now I don't want 1.5, that doesn't really help me. But we talked about how we can do math, enter, to get the simplest one. And I get the same fraction that I did with the ratio there. So whenever we're asked ratio, you're just making a fraction, the first thing that you're looking for, over the second one. So that would also be true. So we're basically, when we're inferring, we're taking this small number of subscribers, because they definitely have more than 40, but we're kind of expanding it out. And that can be good and that can be bad. It just depends. So one more, we'll get a little more feedback now that we've seen how this works. We're selling t-shirts at a dance competition to raise money for the dance team. That's a good idea. In order to help her figure out what type of shirts, she distributes a survey to determine the color of shirt people prefer. And here's all my shirts. So this time, again, they don't tell me how many people total there are. So I'm actually going to figure that out myself first. I want to know how many total people, because that's probably going to come in handy. All right, so there's 395 total people, whoops, that we have in our survey. So, all right, I think you got me on this first one. Coach Harris should order equal numbers of each color of shirt. Would that be a good idea? No. Were all the shirts above like equal in popularity? No. So, this is not true. Okay? Didn't get the same votes for all. Not even like really close. I mean, tie-dye's at 135, neon's at 55. I mean, that's not even like half. So yeah, we don't want to do that. We're going to have people mad they didn't get the tie-dye, and the neons are all going to be sitting there. Okay. Less than 25% of Coach Harris's orders should be navy shirts. So again, here, there's a couple ways we can do it. But again, if we kind of roll along with the way we did it on the last one, if we take the navy divided by the total, instead of having to do all of these at once, so it's like 31.6% want navy. Well, 31.6% want it. We're going to take less than 25. That's a bad idea. We're not going well so far with our ideas here, because neither of them make a whole lot of sense. Sit down. Hi. Thank you. So here, again, we just kind of keep looking. Coach Harris should order 50% fewer gray than navy. Okay. So here I need two things. We're doing gray versus navy. So let's check this out. So, okay, so gray is 80. Navy is 125. So 50% fewer gray than navy. So do you think that's true? And whether it is or isn't, how would we figure out the right answer for this? Here might be another way to look at the question. Is gray 50% or half of navy? Is 80 half of 125?
No.
No! Okay. Half would be like 62 and a half. Okay, we're not going to order half a shirt. That'd be kind of weird. But yeah, definitely not. That wouldn't be enough. So no. Wouldn't be enough gray. So sometimes we got to read in a little bit. And that can get tricky with differences because we might read things differently sometimes. All right, last one. My gosh, Coach Harris. Let's get one of these to be yes. Should Coach Harris order about 2.5 times as many tie-dye shirts as neon shirts? Okay, let's see here. Neon 55. Tie-dye 135. All right, so let's see. If we multiplied neon by 2.5. No, not 25, Hardy. Not 25. They're not that popular. Now, this is one that, again, how absolutely intricate we're going to be is going to depend on your answer. To me, in the big picture of things, if 135 is the number and doing two about, didn't say two about, 137.5 is really close to 135. So I would say, I would give that one a yes. I'd be like, okay, that's close. Again, we're estimating, so it's not going to be a perfect science. but we're just kind of working through some of those a bit. And so inferences don't always have to just be with percentages like this. So just to reference back for a second to yesterday, I was kind of chuckling when we got done because I'd realized later that when I first did this project with a class, I did this with an Algebra 1 class that I did back in 2021. And so the funny part was, let me pull this back for a second. I'll put it back up if some of you need it here in a minute. Let me pull this up from yesterday. So I was looking. So here is my key from when we did this originally in 2021. So I was kind of looking at stuff. Then let me fold this over for what we found yesterday with info. So, I mean, you even looked at, that's some really big percentages, but we talked about yesterday, that's like over 70 years. So, I mean, 15, 20%, okay. But then you pull up, oh, it's going to be too big. Come on. No, that's not going to work. Hang on a minute. Zoom out. I got to be able to get it all in. Okay. So now you look. This is from 1950 to 2021. 2021 to 2024. Oofda. So I get, ooh, fries down. What the heck? You can start to make, now, is it definitive? No. No. Can you make inferences, though, with hey, it looks like the percentage price is going up more now than it was before. And you can start to dig and see things. But other things, it looks like are going down in price. Where'd that go? Where'd my fries go? Oh, right there. Yeah. And so you start to look and you're like, because I think that was, oh, maybe that was small. Maybe that's why it was different. I don't know. But you can start to look and see some things haven't gone up that much. You know, the orange juice thing didn't change that much. Coffee didn't change that much. But some of the other things changed a lot. So you can start to dig deeper and be like, okay, so why are hamburgers and cheeseburgers so much more, but coffee isn't? That's kind of weird. And you can start to make some inferences and dig and get some information and just kind of start going along with the, instead of just going along with the flow here. It's just something to ponder. I found it interesting as I was going, so I'm like, okay. And maybe, and I'm not going to have us do this currently, but maybe if we kind of looked and said, okay, 1950s to 2021, 2021 to 2024, you know, if that keeps up, what would the price of a hamburger be in, I don't know, 2050? And we can start to be like, man, what percentage is it going to go by? It's like a hamburger going to be $10. Maybe by 2030, who knows? But that's just kind of, again, I like to get you thinking. I always tell people math is cool, but not because of the math. It's because it makes you think critically and problem solve. And so, yeah, I just like to get some stuff out there occasionally. So, okay, enough of Hardy's getting distracted onto a side note here. The monstrously large assignment, I'm just kidding, is back in the last page of the packet here in your practice, this big old thick one we've worked our way through. Page 37, there are only 4 problems here. Purposefully done this way. Why am I doing it purposefully this way? Because I want to make sure that if there's any stuff that you started in here before, that you've got time to finish it. Because this is a large practice packet, so it's going to be a lot of points in there. So that gives you some time to do that. Again, I always have answers for you to check in classroom as well. But it also is going to put us in good shape for when we get rolling with this quiz preview tomorrow. So we kind of know what's going on and where to find things and stuff like that. So Hardy is going to jump in on one of these, just the first one, just to make sure we're good. Scientists tagged and released 40 tigers to monitor the tiger population. Later they found 200, 10 of which had tags. Find the best estimate for the tiger population. Okay, so let's start here actually. So we had 10 tigers with tags out of 200 total tigers. Before they tagged 40 and released them into the population. So since they tagged them, that would go up here with my tag, and that's going to help me find the total number of tigers. I'm just going to set up a proportion in that case. I could have done the 10 divided by 200 and figured out what percentage that was, but I honestly think with these, since there's not like a chart there or something, this is probably going to be the easiest route to go. So we're just going to cross multiply. That is a large number, 808,000. Divide by 10. So there's probably about 800 total tigers hanging out in different places for us to see. Again, perfect science? No. Could we be off? Yeah. But it gives us our best chance here with doing the inference. So try those out again. Keys are up, or you can ask me. I can check some things over for you too. But take advantage of the time to get some of that other practice done so we get all the points loaded up here before we head to the last portion of our